AI, what could it do for us, right? Well, theoretically, if we can communicate what our systems are, what their inputs are, what they look like, if we can logically and consistently communicate that to a model, then theoretically, and in practice in some cases now in a limited capacity, they can do the inference for us.
You are listening to The Secure Developer, where we speak to leaders and experts about DevSecOps, Dev and Sec collaboration, cloud security, and much more. The podcast is part of the DevSecCon community, found on DevSecCon.com, where you can find incredible dev and security resources and discuss them with other smart and kind community members. This podcast is sponsored by Snyk. Snyk's developer security platform helps developers build secure applications without slowing down, fixing vulnerabilities in code, open source containers, and infrastructure as code. To learn more, visit snyk.io/TSD.
Hello and welcome to another episode of The Secure Developer. And in this episode, joining me today is Laura Bell-Main, CEO at SafeStack. Welcome to the podcast, Laura.
Thank you so much for having me. It's a delight to be here.
Oh, wonderful. Pleasure to have you. Now, in today's podcast, we're going to have some fun talking a little bit about threat modeling and some of the advances that we can take with AI in threat modeling. So first of all, before we jump in, Laura, I'd love to hear a little bit about yourself, your career, your path into security, and also tell us a little bit about what SafeStack do.
Awesome. Well, I'd love to say that I studied the right qualifications and then I went to the right schools. I didn't. At age 16, I became a COBOL developer for the tax system in the UK. And that was more to do with the fact I needed a job than it was anything else. I'd never coded before in my life. I thought at that point I was going to be a lawyer or something, but life happens. And since then, I've been on a really interesting and wobbly journey. I put myself through my qualifications finally. I went to university when I was a bit older than most and did AI and robotics in Aberystwyth in Wales. And then I've worked for places like CERN doing real-time radiation monitoring software, the UK government doing counterterrorism. And then I was in this weird rut of my career where I was doing enterprise Java, which, is a sad time for most of us. And I found that I'm incredibly curious. I'm the person who, if you give me something, I want to go, there's 3 buttons and I have 5 fingers and how many combinations can I push at once and what happens? And I'm quite playful like that. Now, it turns out as a software developer, that's not very helpful. But my team leader at the time, he was like, Laura, we really like you and we don't want you to leave, but seriously, please stop. Have you considered security? Because that's what they do all the time. And so he introduced me to the security team and I became a penetration tester with time, a red teamer. And then I've kind of come full circle now. I live in this weird hybrid space between security, where I specialize in application security in particular, and software development. And so, I'm this weird hybrid and I love it. I'm genuinely excited about the technologies we're building in the world right now. Mm-hmm. And SafeStack is my ugly baby. So if you as an engineer call all of your tools and things you build ugly, I definitely do. It's lovely to me anyway. We're on a bit of a mission. So I've spent the last 15 years helping teams all around the world go really, really fast and do security as they go. And some of that's tools and some of it is culture and some of it's communication. It's a bit of a wide-ranging thing. Now, in COVID, when we all decided to stay home and cook bread for a while, we decided instead to turn what we'd done in person for a long time into a product. So we now work with about 2,000 organizations around the world, about 89 countries, ranging from teeny tiny 2-person startups all the way up to big banks and airlines. And our job is to try and get everyone in software, not just the devs, but the testers, QA, product, UX, you name them. If they're somewhere near software, we want to play with them. And we want them to do 1 hour of security every sprint. That's our mission in the world. Mm-hmm. So we reckon if there's 30 million software developers in the world right now, that if we all did 1 hour, the impact overall on the amazing software we're building would be phenomenal. So that's what we do. We're an education platform. We have templates, resources, labs, all sorts of great things you can bring into your workflows and make security a little bit easier.
That's an amazing philosophy, actually. And I think it is, from an educational point of view, ensuring teams do actually spend that time and dedicate that time to security. And I think not just as a one-off, but baking it into that sprint. So I love that idea of this is something which needs to be kind of almost prescribed into every sprint, as well as various other, technical debt style things that needs to be done with resilience and other things into that sprint.
Yeah, and I think if we look at it right now, a lot of the way that we've historically talked about security is like this giant monster of a thing. But if you look at all the things as an engineer you already balance with, performance, scaling, usability, observability, accessibility, all of those things, you do every single day. And you do it in minute ways just as part of what you're doing. So we're trying to, instead of security being this huge thing that feels overwhelming, that you don't know where to begin with, that we just bring it in like all those other ilities. It's just part of writing quality software. And so we make that easy, we make it small and achievable, then the net results as an ecosystem are massive.
And it's interesting actually because even on the podcast here we do talk about almost like the destination, ways to get to that destination, but sometimes it's equally, when we think about the implementation, it's about little steps.
Tiny
it's about
ones.
not taking a leap to a new destination, but how can we make small changes today to actually get to that destination? What's the next action we need to take? And I think that's very fulfilling to see those small changes happen. It's like the 1% change in various habit changing techniques, right? So yeah, very, very interesting. And so let's jump into the topic, threat modeling, something that, we've learned about for a long time, we've heard about for a long time. Why don't you give us a foundation about threat modeling, where we are today, and perhaps even some of the challenges that we as an industry experience with threat modeling today?
Yeah. So I'm going to ask you a question first. Have you ever robbed a bank?
Gosh, you're asking me this live on the podcast.
I know, right?
I'll say no. I should say no, right? Yeah, no, I haven't.
No, well, most of us haven't, right? But weirdly, there's a whole set of skills you as a person have that you have forgotten that you have. When you were little, when you were a kid, you would play imagination games. You would plan a bank robbery. You would have Godzilla and Batman fighting it out to protect the dinosaurs from the evil invaders, whatever it was that was your particular jam. And one of the things that you did is that you looked at systems and you looked at environments and you went, oh, right, here's a way that the bad person could do the bad thing. And you did this naturally. And then school happened and life happened and you grew up. And now when we build systems, because we're engineers, we're always focused on the end result, the outcome. But we don't take the time to step back and look at those systems and go, cool, what are the other ways they could be used? What are the ways they could be misused? And this is where the bank robbery comes in. If you were the person in charge of a physical bricks and mortar bank, and imagine that bank had something valuable in the vault, then there are literally hundreds of ways to plan a bank robbery. Now, our movies tell us about 1, 2, or 3. Somebody comes in with a weapon, somebody tunnels in. But actually, there's so many. And every system we build is like this. So planning a bank robbery is essentially a threat model. Thinking through a system that has controls like guards and cameras and brick walls, and thinking about it in a way that it could be used to get to an objective. So in software, you would do this with your application. So not just the one little bit of code you're writing today, but the entire architecture of what you're building, the processes through it, the data that goes through it, the inputs, the outputs, the people who interact with it and the processes. And we look at these not from an engineer's perspective of how do I make this work, but you take a step backwards and you put yourself in the shoes of an attacker. Now, an attacker is objective focused rather than they're not there to go, hey, today I want to do SQL injection. They're here because today I really want more money, or today I want to get political influence, or today I want to read the CEO's emails. So we put ourselves in that objective focus seat. We look at why they would want to act, and then we look at our system with a new set of eyes and we go, right, if I was in this position, if I was planning this attack to get to my objective, what are the ways I could do it? Mm-hmm. And by looking at it this way, firstly, you see your system in a completely different way because you're seeing it not from the intended output for which it was built, but for the ways that somebody else can achieve something that you hadn't had in mind at all to begin with. And secondly, it's a very collaborative process. It can show you across a group of people how complex and how diverse the pathways through your systems are. Mm-hmm. So threat modeling in itself is a whole bunch of tools and techniques, and there's free ones and paid ones and everything in between. But the consistent part of all of them is a systematic way to look at what you have built or what you are about to build, from an objective point of view, such that you can look at the pathways through your system to get to those objectives and therefore identify risks that might be in your design, in your architecture, or in your implementation.
And I think from a developer point of view, it's not, I agree with exactly the way you said it, whereby sometimes we're almost like too internal. As developers, we kind of like look into our system and try and identify what is the objective of my functionality, my feature. And I think too much about the golden path. Think about that. Okay, I'm trying to get this to do X, Y, and Z. Once it does that, I now focus on the next thing, or I think about it in that way. And the way you describe that is almost counterintuitive to a developer, right? Because they almost have to stand from the outside in and think about it differently. And rather than the way it's supposed to work, how can I almost break this? Or how can I think about it from the objective of what I as an attacker might want to get, irrespective of what it's supposed to do or how it does it? Are developers, when we talk about kind of like traditional threat modeling, are developers the best people to do this? Or is it, who do you feel needs to be in the room for this kind of exercise?
So I love making these a team sport. So absolutely, we want the engineering team there because they know how the thing is strung together. But your QA folk, for example, now QA, no matter whether you are manual testing or automated, we don't judge. The way you think as a tester is actually closer to that threat modeling naturally than any other part of your team. They are the type of people who go, ooh, what if? And if you haven't got those people on your team, you need to find a what if person. In fact, there are companies in the US in particular who there was a little song and dance once upon a time because they were hiring out of work script writers to come into threat modeling sessions with them just to be that chaos person who would go, oh, yeah, but what if? And you need that voice there. The other folks you might want to consider, which are completely outside of your software team, are your customer experience, customer success people, because they know how people are using your system, because they help them every single day. If you're in a bank, to go back to our example, you'd always want a teller. You'd want somebody who'd been working physically in that bank for a number of years, because they're going to tell you that, oh, yeah, well, the controls are good, but we know that if you put this chair there, you can't see anything on the camera. Or we know that every Tuesday, there's a shop over the road that has a buy one, get one free offer on donuts. So we all go out for donuts on a Tuesday and we close up the bank for 15 minutes, but don't tell anyone. You need the people who are operationally involved in the systems to give you that perspective of not just how you think they are used, but how they are used. Mm-hmm. And the more depth and the more diversity you get in those opinions and those perspectives, the richer your threat model is going to be.
Yeah, I agree. I think it is a team sport. There is no one individual that knows everything about whether it's the system, the usage. And I think adding someone from the customer, not the customer side, but from the customer success or someone who's very close to the implementation about how people use it is really, really important. In terms of who owns the process, though, who should get all those people into the room? Who's responsible to do that? Because the value of threat modeling really is doing it nice and early as things are being designed so that you can almost like make the right decisions about how you architect and design things that later on in the implementation, where you get vulnerabilities potentially being implemented that could be completely avoided by doing things a particular way early on. Who's the right person to say, hey, we should be threat modeling this, or I need to get the right people into a room to do this? Who would you say?
This is where it all falls apart. This is where we've got a bit of a problem. So there's a few schools of thought on this. And, those people who are listening, watching at home, you might be able to reflect on this as to what your organization looks like. Now, we did a survey of about 2,000 organizations. We looked at how many engineers they had, how many security people they had, whether they were joined together or whether they were siloed, and what percentage of the overall workforce this represented. Now, the reason we did this is we had some hypothesis. We were like, if you're a tech company, you're definitely going to have a security person. Spoilers, they didn't. And that security person is going to be really, really embedded with software team. So the security folk can say, hey, we're going to do some threat modeling, and they can help champion that, take some of that effort off the dev team, because our dev teams are super, super busy already. How many of us can actually look at each sprint and go, oh yeah, I've got a few extra hours to spare. That'll be fun. We're not. We've got way more work than we've ever done before. And the pressures on all of our companies and our teams are really high at the moment. So we had this hypothesis that there would be a team. You could ask your security folk. And if you're in that environment, you've got a security team, an AppSec team, and they can help you and they can facilitate. Fantastic. Be very grateful for the situation you're in, because it is unusual. Most companies, If they have a security team, it is quite separate from development. And many of the security folk come from different backgrounds to engineers. They're not necessarily people who have built software before. They might be networking folk or risk and compliance. Now, that's not a problem. It just means that they don't have the understanding needed to really own this process and to work it through. They also may not have the relationships with the dev team to really speak the same language. And that's what causes a lot of our friction over time. It's what DevSecOps was trying to fix and sort of didn't. So what we can do here is we need to kind of be really honest with the environment you're in. If you're in an environment where you don't have an AppSec or an engineering savvy security team, firstly, go make friends with whatever you have. You're going to need them in some respect. And secondly, it means it's got to fall into the dev team. Now, what we see commonly happen here is the Batman problem. Now, the Batman problem is one person in your dev team will be super enthusiastic about security. And if you're thinking about your team now, you can probably think of that person. Now, what happens is that person just keeps doing things on their own. They're the person that kicks off the threat models. They're the person who makes sure the tools run. They're the person who triages things. But Batman has a real scale problem. So if you're in Gotham City and you're Batman and you've got 5 murders going on at the same time, how do you choose which one you're going to do? Well, you get a backlog and you put them all in Jira and, eventually you choose which murder you're going to handle and then next sprint you handle the next one, right? But that doesn't work. That superhero mentality just means you end up with a backlog and eventually Batman gets really, really tired and just retires. And then you've got nobody, just this growing backlog of bad things happening. So we need to make sure that it's not just one person in dev, it's actually something that we're sharing amongst our teams. So we have to find a way to enable that that's respectful of the constraints of dev teams at the moment. So it needs to be something that is easy to do. So there needs to be a template, there needs to be a model that we know how to do this. This is how it rolls, and we make it super friction free. We need people on hand who can facilitate. So you need somebody with energy in that room who's going to go, cool, let's do this. And it doesn't need to be one person across the whole team. It needs to be a group of people who actually care and can come and do this with you. And then we need to make sure every single team is empowered and also held accountable for doing this. So it's not saying, hey, you can do this. It's saying, you can do this. We have enabled you to do this. And also we're looking and we notice that you're doing this and that's a good thing. Oh, we're noticing you're not doing this. You need all of those parts in play. So sadly, it's going to be in the dev team. If you're feeling very tired and stressed out already, take a break, have a cup of tea. You don't need to do it now. But it is something we need to find a way into our world.
And I love the idea actually there of Batman having a Jira backlog. I think that's if there's one takeaway from this at all, it's remember even Batman uses Jira and has a Jira.
Absolutely, and it makes him very sad. That's why he's grumpy.
Yeah. So let's move the conversation more into AI now and talk about, obviously a lot of those problems, we're even just mentioning AI, we can start to kind of like piece together how an amount of automation in AI can kind of like play a role in this. Where do you see the future of threat modeling with the addition of AI? And I guess, first of all, how do you see AI playing a part into the process of threat modeling?
So there's 2 sides to this, and I think we need to talk about them both. There's AI and the effect it has on the threat models that we build, because how we threat model AI is different to how we would do a linear system. I'll come back to that in just a second. And then secondly, how can we use AI to help with this process? So I know there's folks at home who are going, oh my goodness, the snake is eating its tail. It is going to be a bit like that, so bear with me. But let's start with the first half of that problem. When you threat model a current system, a non-AI system, it is linear. So if I have an algorithm that I've implemented and it's got steps 1, 2, and 3, and if I always put an apple in, steps 1, 2, and 3 apply, and out comes an orange, then I know that I can map all of the pathways through that code base, and I can understand and anticipate all of the outcomes of every permutation of the logic I've implemented. Now, that takes a very long time, but it is achievable. And so you can map out your systems in advance and you can be kind of predictive of, okay, here's where the bad things can happen and here's how I would know. The problem with AI systems and the increasing use of them, and I'm pro team AI, so I'm not saying don't use AI, I'm just saying great power, great responsibility, et cetera, is you've got this box in the middle. Now, that box in the middle is some form of model. And I'm oversimplifying a massive space, so forgive me at home, people. I know you have feelings and opinions, but let's call it the big black box in the middle of AI. Now, either you built that, so you have some understanding of how it works, and you trained it, or you're using a third-party model that somebody else has done that work for. whichever it is, by nature of what they are not finite pathways. They are evolving logic models that can change with time, that can change with what they're trained on, with what data you put into them. And as a result, we can't for any more say, hey, if I put an apple in and I put it into my big black box, then an orange is always going to come out the other end. Because you never know that if it's been trained in a certain way or something influences, suddenly an elephant's come out. So when you're threat modeling, it's all very well and good for us to say, map out your whole architecture, look for the malicious pathways through it. But if one component of that has a degree of uncertainty or evolution, then it becomes very difficult for us to be as sure about those predictions, about those threats. And we need to be really mindful of that. This gets incredibly complex if it's not your model. Now, I've no problems at all with people having third-party models and you integrate with them. I get it. I totally do. But if you are doing that, so you're integrating with a third-party system, whether it's OpenAI's models themselves, and you're using those kind of tools, or you've found an alternative that you're plugging into, you've got to be very, very careful that you're understanding and have an explainability, if you will, over what is happening in that component. Otherwise, threat modeling is going to be very, very difficult to get the value out of. So that is kind of the big difference and change that AI is making to the models themselves. On the other hand, then there's AI. What could it do for us, right? Well, theoretically, if we can communicate what our systems are, what their inputs are, what they look like, if we can logically and consistently communicate that to a model, then theoretically, and in practice in some cases now in a limited capacity, they can do the inference for us because they can work the pathways, they can look at those inputs and outputs. Now, they're not as creative at this stage as humans. There is a degree of this that actually the creativity we have as a species, that ability to adapt and improvise very quickly from unknown or uncertain data, is a real big advantage in security, particularly in threat modeling. But they can do the low-level stuff for us. Now, even before AI was a thing, we had Microsoft released tools like Microsoft Stride, which is a threat modeling framework. You can go and grab. It's open source. And it stands for spoofing, tampering, repudiation, information disclosure, denial of service, and escalation of privilege. There is a test at the end. So answers on a postword, if you remember those. Now, they built tools even 15 years ago that you could map out and draw your architecture, and it would come up with like a low-level threat model for you. It's all the low-hanging fruit type things. AI systems are now taking this the next step up. So you can communicate your architecture, communicate your data model, but not the data in it. You wouldn't want to do that. And it can then start looking for those low-hanging fruit, those common, this might be used in this way. Mm-hmm. So that's kind of the state of play at the moment. Now, there's a lot there. Simon, where would you like to unpick next? Because otherwise I'll just keep talking and your audience will be like, she never stops.
Let's start with that first half. So I think we've got two pieces there that are really, really interesting. Now, that first half where we're trying to perform threat modeling on your application, a feature of your application, that pulls in, maybe it's a new AI model and potentially even, like you say, models that you don't own, you haven't trained, but potentially someone else's model that you pull in. I'd love to talk about some of the kind of biggest threats that we have there, because I guess the threats of the model itself, and that could be anything from, we can talk about things like prompt injection that we know is already a big threat. And it's been well documented about the path that attackers can take through models with using things like prompt injection. Other things, for example, about the way these types of models are implemented, like you say, whether they're next to our data, whether they're using our data and things like that. What would you say, I guess, are some of the newer things that we have to think about that we can kind of pick up from a threat modeling point of view? What are the most dangerous aspects of using an LLM in your application from a threat modeling point of view?
So I can actually point you at something you can go home and read as well. So the nice bit about this section is it's not just going to be me talking. You also get homework. Good luck, team. So Kendra Vant and a whole bunch of very smart people in the OWASP space, so Open Web Application Security Project, have released the first OWASP Top 10 for LLMs. So as well as what I'm about to say, I highly recommend you go and have a look at that OWASP Top 10. This looks very different from SQL injection, cross-site scripting. It is a different way of thinking. And it can be a really great way to start thinking through the layers, the challenges with, I almost said problems, but the challenges with LLMs. But if I was going to break it down and kind of give you the high level, so some cliff notes, if you will, and there's a few things you want to look at. Where did the model come from itself? What is it built from? Now, there's sometimes you're going to have a lot of visibility on this. If it's open source, you can really dig into these things. If it's not, you're going to have a conversation with people. What is underneath this? What is the algorithm? What's been used? And sometimes they'll share and sometimes they won't. But you have a responsibility if you're using software, whether it's picking an open source library to use or using somebody else's model, we have to do our due diligence and go, hey, what is inside this magic box? Is it okay to use? And so first tip for you is to start thinking about what are the questions I'm going to ask of every model that I start working with, because then you can turn that into a little checklist that you can do and kind of make it a consistent process. Outside of the model, you've also got the training data. So training data is fundamental. You need it, and you need really high quality training data to have a really good quality model, because essentially a model is regurgitating that training data predictively. It's looking for patterns and combinations of those bits of data. Now, you don't always get to know where the data has come from, but you should be able to ask things like, is this still training? Is the data that's being put into this being used to change the algorithm, to change the data model? If it is, then you know how quickly that's going to be changing. If it was trained once statically but is no longer training, that's different. So in those circumstances, you can say, well, all right, although I can't predict all of the outcomes here, there shouldn't be any big surprises because there isn't anything new coming in. It also talks about a risk there. So one of the risks with a model is how it's trained. If you can put malicious data into a model to train it, that model will reflect whatever was put in. So much like in any software, garbage in means garbage out. Evil in is evil out. So you want to be making sure that you're understanding how data is vetted before it is used and what controls are there to make sure that malicious data isn't entering. Now, as well as malicious data, you probably want to consider bias as well, because bias data can also give you really unpredictable and unsafe results, just not in a traditional security way.
Yeah, and I think everything there from ethics as well as morality and biases and things like that are really, really important.
Absolutely. We all end up having a software developer's existential crisis at this point. So we've got our data, we've got our model, and then we've got what we're doing with it. Now, what you're doing with it, there's technical vulnerabilities, things like prompt injection that were just mentioned here, that the OWASP Top 10 for LLMs does cover in quite a lot of depth. And there's quite a lot of good primers out there on that. So I would recommend going and having a look at some of those. But the other side is, how are you using the output of this model? Now, you have to treat every piece of data in a system as untrusted. That's kind of like core rule of software security is trust nobody, trust nothing. Now, we're not that great at that, even with non-AI systems. So there's a lot of systems out there that if the data comes from an external user like me, I'm not going to trust it, going to do lots of validation. But if the data comes from another microsystem in my architecture, oh, that's fine, it's come from internal, I won't do so much. And that's a really dangerous assumption. Now, the foundations of zero trust are that we don't do this. So everything that comes into us, we verify, and that we do our analysis on to check that it's suitable to use. And our AI components are no different. We need to make sure that whatever comes out of them, that we don't just take it at face value. Are there checks and balances we can put in place to ensure that that outcome, that analysis, that result, whatever it is you're finding, is suitable to the context, that it's safe to use, that it's trustworthy? Whatever your context is, it's going to look different. If you're in a financial system, that's going to be a very different thing. For example, it could be a credit score, or can I lend on this loan? If you're in a CRM, it could be enriching data. So it could be saying, hey, you've got this customer record. I'm going to pull you extra information and give you some insights into your customer. There's lots of applications. And for each one, you need to look at, right, what is the data that this model is giving me? How can I verify it? How can I flag whether it's safe or not? And what is the impact? What is the result if this data is not trustworthy? So in a financial system, for example, if the decision to lend or not lend is based on an AI engine, we would probably need to put some scrutiny in that took a sample set of those decisions over a period of time and still ran them through a manual verification process, just to double check that the logic rules we hope are being applied are in fact being applied and that the decision is fair.
Yeah.
You can see how that would apply to an immigration system, for example, if you're using AI to determine if somebody was valid for a visa or not.
Yeah.
And in your company side, sorry, I'll just finish that little bit up. In that company side, although it seems less important because you're just pulling company data to enrich something, if you're basing your sales workflow off those enriched data pieces or doing automation, you can cause a heck of a lot of disruption in a company and damage their reputation by getting that wrong.
No, absolutely. And I think the OWASP top 10, I think, refer to as part of that as over reliance, right? In terms of leaving that day. And actually, one of the things which I love the way they say it is pre-input even as well as output from and to an LLM as you would user data, which I think is a core kind of like rule to think about. When we do think about threats like prompt injection, which I believe the OWASP top 10 puts as number one, it's exactly what you said. It's unpredictable in the sense of, we don't know necessarily what a user is going to provide to it. And there's an infinite number of inputs that a user can provide that. And again, there's going to be an untrackable number of outputs that the LLM can provide us with. Is there a foolproof prompt injection mitigation that we can use? And if not, I think you alluded to it there, guards and things like that, being able to validate and verify output. Is this the technique that we should be using for these kinds of eventualities?
Yeah, I could be really facetious and say you could just turn it off. That's the best way to protect against prompt injection. But no, there isn't. But there's no foolproof way to get past any vulnerability in software. We've had SQL injection vulnerabilities known about for now 20 years. We still see them. And that's because there is no guaranteed solution. And that's okay. Part of being good at security is accepting that there is no magic box that is going to do this for you. There's no, I missed a button, turn on the button and you're fine. But it just gives us that responsibility. And you're right, it's guardrails. It's having shared patterns in our teams. A lot of this is new. You can't teach this at university. It's genuinely going too fast. Most of us, even those of us who, personally passionate about this area, there's so much happening every day that it is incomprehensible how much change you're working with. So the best thing you can do in your teams is make this a known and shared problem. So make it a fun thing that you do once a month. You get together for lunch or whatever, try and get your boss to buy pizza if that's your thing, and come together and go, cool, what changed in AI this month? And what does it mean? And really start collaborating and sharing, because there is not one of us that is going to be able to come up with the perfect set of guardrails or solutions or fixes for this. And some of the best people positioned to come up with anything right now are not security folk. They are engineers. This is probably one of the hardest security engineering problems we have ever seen emerging. And it's not going to be someone who has a networking background who fixes it. It's going to be people who are knee deep in these systems and code and really understand how they work and can collaborate in a way that is going to show us, okay, this works in this circumstances and these are the limitations. And you need all three pieces, no magic boxes, just, okay, we can do this. It will work to this degree. Be wary of this. And the more we can share those kind of things, the stronger we're all going to be.
Yeah, it's really good advice. And I also kind of like with things like that, with almost assuming something like this will and can and will happen in terms of like, yeah, maybe we will have an attack on prompt injection, maybe an attacker will be able to get through. It's risk reduction. Ultimately, do we have everything else correct behind the scenes in terms of principle of least privilege, in terms of data access and things like that, so that if something like that, maybe we think when something like that happens, are we best protected internally to the potential damage that someone could do? And I think that's almost where we are, right, for those kind of risks at times.
I think we're going to start seeing a change in the way we talk about how we measure success in security as well. For a very long time, we've been focused on, we had 10 bugs in our software this month, and the month before we had 12, and therefore we're making progress. But when you're looking at systems holistically, as you have to do in AI, that doesn't work anymore. They are rapidly evolving such that if everything stayed the same and you could say there are more or less vulnerabilities each time, that would be a valid metric. But when the system itself evolves exponentially quickly, then you're not comparing the same thing each month. So what we're going to start seeing come through is more focus on leading indicators. So looking at things like how many issues did you identify in security this month versus how many did you change? Looking for actions that are consistently applied throughout the whole SDLC in ways that you can say, right, my whole team is participating. Every part of my system has been involved in this process this month. And we know that we're not just identifying, but we're addressing. And it's looking at that much more like a continual process and a culture than it is just is it safe or is it not? Is it secure? Is it not?
Yeah, and let's move on to that second piece actually that you mentioned earlier in terms of using AI to almost like determine various threats in the application and being able to identify that to almost like allude to some of those metrics that you were talking about there. When we do assess the threat analysis basically of your application, you mentioned you would tell the modeler about your application. Do you ever foresee, for example, an LLM based threat modeler whereby it learns about the application and it tries to identify itself? Or do you see it more almost like a tool that learns from our teachings about the application, about the architecture, about the usage, to then almost like try and extract the output from it as to where the various risks are? I'd love to hear your view of how that will.
Awesome. Please note that, like all views you hear on the internet, there are many and they vary. I think we're going to see generations in this. So I think in the first stage, what we'll be seeing is AI tools that can facilitate processes. So it's very difficult at the moment for you to give enough information to a model, even if it's a model you've built yourself, that could coherently understand what your application, your system is. What artifacts would you need to feed into a model to do that? Yes, the source code is one thing, but then what about your architecture? What about how it's being used, your logs? And then there's a heck of a lot of risk about putting all of that kind of information into a model unless it's a model that you've trained yourself. And that's a lot of work. So I foresee only really the top end of town doing that, the very big organizations doing that level if they chose to.
Mm-hmm.
But what we can do that's much easier is that we have lots of proven models and thought processes and question sets that we have used for threat analysis before. So whether it's attack trees or whether it's Stride. So by teaching those frameworks to a model, the model could, in its own way, begin to coach us through thinking through these processes. Mm-hmm. And I think it's not as glossy and exciting. It's not a magic bullet, but it's a facilitation. I think this early generation of AI assistance in threat assessment is going to be efficiency. It's going to be productivity tools in a way. How do I make this easier? How do I make the results of this easier to get into the systems I need to get them into? Mm-hmm. How do I make sure that I can do this in a way that, there's been 15 pull requests on my system and it touched that authentication bit. Maybe we need to do a threat assessment now. And it decides whether actually enough has changed that we need to think about this again. Those kind of enablements are going to be really, I think that's very short term. We'll see those in the next 6 months to a year. Longer term, we still have a lot of questions about the safety of the amount of data you would need to put into a system to truly threat model it. Like I said, if you can do that internally, fantastic. If you're Google, I'm sure that's completely achievable. But if you are a 500-person high-growth company somewhere, this is well outside of the range of what you can do. And if someone does offer you a tool that can do it, then you've got some really big, challenging due diligence questions. How is your data used? Is it being used to train something? Who else can see it? How long do they keep it for? And there are not proven models right now for safely having those conversations, those negotiations. So sadly, I think we're not there yet.
All those wonderful, fun privacy conversations that we've been having most recently as well, right?
Absolutely.
Yeah. So at the start of our discussion, we kind of like talked about that room where you have developers in it, you have some security folks in it, you have, some folks who are close to the end user, the customer, who can all provide their point of view. I guess now when we pull up another chair for the AI tool who can help us threat modeling, is this a new chair? Are they taking someone else's chair? And who is most interactive with this new wonderful AI tool that we have?
Oh, I don't know. It's really hard, isn't it? I think the AI from an input perspective is going to be very tightly entwined with both the systems that we're building, so source code, architecture, that kind of thing, but also our customer support and success, thinking of things like semantics in trouble tickets, all of those kind of things are going to be really useful, and log ingestion. So I think there's a variety of players that need to be involved in the feeding and watering of the system and making it as useful as possible. I think at this stage, it's most likely that the dev teams themselves will have the most interaction, but I would query whether it was those who are writing code or whether there's an opportunity here to give some superpowers to some members of our software team who we often overlook the influence they have. So, for example, our product people. Product people are really, really early in the process. The business analysts, the people who are trying to understand that problem and articulate it in a way such that it can be built. So I would say that, yep, absolutely our developers right now, but with time, wouldn't it be amazing if actually we brought it even earlier in the life cycle and that our product people, our business analysts, our UX designers could all use this as a tool to simplify security by design so that by the time it got to implementation and that grooming phase there, a lot of those things had already been considered, already taken into account.
And a lot of the time, we actually don't ask ourselves enough when we do threat modeling. Do I have the right information? Do I have enough information here to actually make a reasonable decision about the outcome of this? And that's actually one thing that AI does reasonably well at times. It kind of like says, well, there are various opinions on this, and sometimes stutters before trying to give you an outcome. I did that just today where we were talking about whether Die Hard was a Christmas movie. And I had to ask it 3 or 4 times before it said it was. Maybe that's a bone of contention, but it's interesting, that I can see an AI system like this being able to say, well, actually, I don't have enough information about this piece of the system. And where we as humans might say, well, actually, I'm almost not asking that question as to whether I have enough information to make a good call. Maybe I'll just make that call because it's my gut feel, or you make it with too many assumptions, perhaps. So it's almost like that nice piece where it can determine itself in an automated way, ask that question of, do I have enough input here to make a reasonable enough judgment?
I'm going to go deep though, because the second we get into this, we get into the same problem you see in medicine. So if your AI system is going to say, hey, I can't do that, Dave, we don't have enough information, but your lead engineer can still press the button and go, well, I'm going to do it anyway, because my gut instinct says it's fine. Now, we've got a bit of a danger. In medicine, what happens is we have a lot of med tech systems that can say, hey, do you really want to prescribe that? It has a counterintuitive kind of situation. It's going to have effects with this other thing and people might get hurt. But what can happen is the more senior you get as a medical professional, you can override these things and say, no, I know better. Now, in some cases, that's the right choice to make, but in some cases, it's not. And so we're going to have to be really mindful as humans that we take a little bit of stock, that we have some self-awareness of when to trust our gut and override the, hang on, we need more information, and when we need to go, all right, then, computer, sure, who do I need to talk to? What information do I need? And I know from my own perspective, I've been guilty at times of going, evidence, it's fine. How hard can it be? And just pushing the button. So I think we're going to all need to be our best version of ourselves if we're going to take advantage of the fact that the model might be able to spot gaps that we haven't spent the time to look at ourselves.
Yeah, and I love that extra step of effective validation and verification, really, about when, that judgment call, whether things are right or not. It's been lovely to chat with you, Laura. And I'd love to kind of ask one final question, staying on the topic of AI. And that's really, if AI were to take a piece of your job away, whether for good or bad, what piece would you like that to be?
Actually, AI is doing a really good job of some of the boring bits of my life. So I'm quite pleased. I'm going to pick something from my personal life and break your rules a bit. I have 2 daughters. I have a 5-year-old and an 11-year-old. And between them, they're obsessed with Harry Potter, Paw Patrol, and a number of awful TV shows that they think are the best thing in the whole wide world. So for me, writing coherent crossover fan fiction that I can deliver in 5 minutes at bedtime without having to, often at bedtime I will get asked, hey, I need a story about Skye from the Paw Patrol who meets a dragon and Harry Potter and they eat a burger with a cat. And sometimes I'm okay to do that, but sometimes I'm just too tired.
Yeah.
So the magic AI storytelling bot would make me and my children a lot happier, I think, sometimes.
That resonates so strongly with me. Right now, I'm telling stories to my kids called The Great British Bake Off, which is a cross that I'm making between our 2 dogs on The Great British Bake Off. So that resonates so strongly with me. So yeah, wonderful.
That's amazing.
Well, Laura, it's been a real pleasure chatting with you, and thank you for all your insights. And I'm sure people will have absolutely, learned many things on this and taken many actions as well for their team. So thank you very, very much for joining us on the Secure Developer.
Yeah, thanks for having me. It was a lot of fun.
Wonderful. And thanks for everyone for listening. And we look forward to our next episode on the Secure Developer. So thanks for listening. Speak to you soon.
Thank you for listening to The Secure Developer. You will find other episodes and full transcripts on DevSecCon.com. We hope you enjoyed the episode, and don't forget to leave us a review on Apple iTunes or Spotify, and share the episode with others who may enjoy it and gain value from it. If you would like to recommend a guest or topic or share some feedback, you can find us on Twitter at DevSecCon and LinkedIn at The Secure Developer. See you in the next episode.